Chala. Okay, all right. So today we are going to discuss very important yet confusing this subject, not subject exactly, but the part of the subject of what we can call it, not even exactly characterized in inorganic or organic chemistry, but I think it is related to something called general chemistry. So one other things, my apologies that I am appearing quite on unusual gap, because since my last video was I think it was a months back if I am not wrong, but it's later. However, due to some reason I was busy in my own stuff, so I couldn't put in video on a regular intervals as one should do while being in online teaching. But yes, today we will discuss one very important and confusing topics that we all students of all levels generally face in chemistry. So what is it is? Generally the three terms that we often heard here is a hydrolysis, number one. Second thing is solvolysis, and number third is dissolution. Dissolution, isn't it? These three words which often we encounter in course of learning chemistry, that are confusing very often. So how we can resolve all these three terms and can fix it forever, that whenever we face them, they never lead to any kind of confusion. So we will tell you to some important key points that where we actually do face it. Generally, when we are studying physical chemistry or inorganic chemistry, especially the topics like ionic equilibria, we often face the word called hydrolysis. Another time, when we studying organic chemistry, especially the topic that we often is associated with the reaction mechanism. When we are studying organic chemistry and dealing with the part of reaction mechanism, we often happen to listen the word called solvolysis. And when we are doing some experimental part of chemistry, we face the word dissolution or solution. When you are dealing with a solution, if you have to dissolve something and prepare solution of some metal salts or any chemical, we use the word dissolution, that whether it's going to dissolve in this solution or that solution, it will dissolve at what rate and what would be the dissolution extent, what order of solution it will result into finally. These things are generally dealt when you are doing chemistry and having your getting your hand dirty, experimental part of chemistry. So these are three terms that often they look similar, in fact. They look similar, and yes, if I say truly, they are similar. They are not very far apart in their meaning and in their actual philosophy. They are not far apart. They are related. That's why they are leading confusion. But yes, they are different. They are not all the same. So that's the problem that we are going to tackle today, and we'll try to resolve in a very smartest and smallest manner. And just to resolve all these three, I would like to write three reactions. Specifically, and you have to notice it very carefully. These three reactions, rather three categories of reaction. Let's say, if we are writing this one, we often see this kind of reactions. Many of you would have by the time deciphered that what kind of reaction is this. Second thing is, we often also see the reaction of kind like, let me draw the structure. I'm making some representational structure, not the true exact one. You might have heard it before, very well before. This is called something carbohydrate. This is basically carbohydrate molecule. And when it is also dealt with or treated with water, what happens? Free glucose molecule or free monomeric saccharide molecules of the kind as a preliminary sugar would have been. These kind of reactions we often face. This is the second type of reaction. And third one is this: if you are trying to dissolve some kind of salt, like say you are dissolving salt in water. All right, salt in water, and it results something kind of this kind of thing you may result into. This kind of things you may result into. All right. So, if I try to use these words with these three reactions, how these words will apply to? The first thing is this: you may have better heard of something called ester hydrolysis. Ester hydrolysis, isn't it? This is called ester hydrolysis. Typically, it is known as ester hydrolysis. So, what the word is being used here? Hydrolysis, isn't it? So, of course, this kind of reactions, as to be it ester or amide or any acid derivative of that kind, if they treated with the water and it get dissolved into two moieties, it is called ester hydrolysis. Okay, this, what do we call it? This is called hydrolysis. Hydrolysis of what? Carbohydrate. Carbohydrate. And this is what, when we prepare a solution of some salt or dissolution. Dissolution means dissolve, having salt dissolved into the water. These three kind of terms we often heard, isn't it? Is it okay or not? And third, and another thing called solvolysis, although you can apply the first one called solvolysis, but if this water is replaced by some other non-organic solvent, this process could also be called as solvolysis, because solvent is doing the job of water molecule. So, in the name of water means hydrolysis will be renamed in a general term called solvolysis. Okay. So, these three words apply to this. Now, you can see that these three reactions basically work in a different domain. This is the part of thing where you are doing organic chemistry or learning. This is generally if you face biochemistry, because you know this is what? This is ester and this is water. When the reaction of ester and water leads to what? Acid and water. Okay, no, acid and alcohol, sorry. Acid and alcohol. Alright, this is the reaction of what? Carbohydrate reacting with water molecules, means it is freeing two moieties of this carbohydrate. Basically, if you fix this X is equal to 2, this is disaccharide sugar like maltose, sucrose, fructose, whatsoever, maltose and sucrose kind of. Well known sugar is sucrose, table sugar we call it. Sucrose has a two moiety, glucose and fructose. When it reacts with water, it frees what? Two moieties, that is made up of. Okay. So basically, when you react a sugar, it may be, when you react any carbohydrate molecule, it may be disaccharide sugar as far as the example considering here as a sucrose, it may be even trisaccharide, even polysaccharide sugars, isn't it? It may be even glycogen, which is a bulkier and a bulky polysaccharide carbohydrate molecule. When they react with water, what happens? Their independent units got freed. By the breaking of what bond? This bond is called as? This bond is called as glycosidic bond. Glycosidic bond, isn't it? Glycosidic bond. What this bond is called as? Ester bond. Ester bond. This is called an ester bond. This is called glycosidic bond. And what bond is it involved here? Ionic bond. This is what? Ionic compound. So it is linked with ionic bond. Okay. This is linked with ionic bond. Alright. Now what happens? When you just react with water molecule, what happens? There is a H moiety and there is a OH moiety. First, this water molecule itself gets breaks down and it's associate half of the part with the first moiety, another part with the second moiety. Alright. Means in one side it will get OH, another side it will get OH. And where this has actually come from? This H has come from this H side and this OH has come from this side. Alright. Ultimately what had happened? Glycosidic bond has broken up and water molecule have been absorbed into this process. Exactly. If you reverse this process exactly, what will happen? You have to add, what will happen? You have to add this molecule. There will be a relief of what we call water molecule. And it will again get formed. This reaction is called as condensation reaction. So in fact, in this sense, hydrolysis reaction is something called reverse of condensation reaction. Reverse because condensation reactions are reactions when there is a two or more than two molecular entities get associated to form a single moiety and there is a release of a molecule called water. This process is called as condensation process. Means if you reverse this process, means if there is a molecule, bigger molecule of two or more than two moieties, and if you add a water molecule into it and these two moieties get free by the breakage of a bond, this process will be called as hydrolysis. So hydrolysis and condensation work opposite, exactly opposite. Means this process is what? Hydrolysis. And this process is what? Condensation. So exactly opposite of each other. Alright. In this process, this process technically known as ester hydrolysis. Means what happened? The H part, means OH part goes to associate with this side and H part gets associated with this side. Means H is from H side and this OH is from the other part of water molecule. And if you reverse this process, what will happen? It will release a water molecule, that's what we call esterification. This process is called esterification. Means esterification is also a specific name to the process of condensation. Condensation is a broad word, isn't it? Condensation covers anything when there are two or more than two entities associated to form one. Alright? Means esterification is a type of condensation where alcohol and acid molecules get associated to release an water molecule. And when the reverse happens, the process is what? Ester hydrolysis. When the reverse happens, this process is known as carbohydrate hydrolysis. Both are hydrolysis. All right. If one has to look at the technical meaning of hydrolysis, the word comes from Greek terminology. Hydro means you all know water. Lysis means second part is to unbind. Means any process where there is a breakage of bond is included that leads to a breaking of bond with the help of water molecule. That process are called as hydrolysis process. All right. Is that okay? Now, if I put another example to clear it, solvolysis, if I just say that this is a salt of an acid, RCONA. This is what we call salt of carboxylic acid. We add a water molecule and what will happen? RCOH plus what? NaOH. Isn't it? Means what is happening here? Here you can say this process is a solvolysis as well. This is also a salt hydrolysis. But you are adding a water molecule and this is not, you are not adding from separately. This is actually a medium. There is a medium, you have a glass of water, you have a beaker in which the water is filled, you add up to what? Sodium salt of this acid. Ultimately the process would be hydrolysis, but since the whole water is not an agent of hydrolysis, mere agent, but it is the whole solvent, so in that sense it is called solvolysis. Okay. Alright, there are other organic chemical reactions typically well studied for solvolysis. So there are many kinds of solvolysis in fact is a hydrolysis, so very much similar. Okay, but this process is little different. The difference is little here because I have used a separate word what we call dissolution. This process could be even hydrolysis and could be what we call just mere dissolution. Now we come to the technical point that why this terminology is vary. Let me come to the other aspect. What are the other aspects? Be clear to you in a while. Because when we do this way, process is called something different. When we do the other way, the process is called something else. So there is something inside it. Okay. Then I am picturizing two processes. I am picturizing the one process that I have written earlier first. This is called ester and this is called what? Water. Added this, the reaction has happened like this plus ROH, alcohol. And I am writing NaCl plus water, the process happening NaH2O and M plus Cl minus H2O X. Better write it here like this. Now this process up to here, it is simply, you can say dissolution. But another thing may happen from here. If any other water molecule H2O react with this and this kind of moieties get formed, H2O N minus 1 OH, charge will be obviously neutral, plus H3O. If this process happens, here you use the word hydrolysis. Up to here, this is a simple dissolution of salt, of a salt. But here, what had happened? Hydrolysis of hydrolysis of metal aqua complex. Alright. Up to here this process is hydrolysis, and here this process is, up to here this process is dissolution, and up to here, from here now onward, this process is hydrolysis of metal aqua. Now one thing you are able to clearly see it, means here if you look at exactly what has happened, the process in this way, what happens like this, there is a molecule called OH and H. Alright. What happens when this breaks up? This part goes with what? This side, and this part goes with this side. Means H and OH ions, OH negative plus H plus ions get distributed into different part of molecules. Means H participate to this molecule, OH participate, go and adds to this molecule, and H go and adds to this molecule. Means two part of water molecule itself, when it breaks down H plus and OH minus, get associated to different new molecules that are resulting out of the hydrolysis process. But here, is there any case like this? Water molecule has not been even broken at all. Water molecule has not been broken. It is exactly going to associate with this. So there is no hydrolysis. Of course, the bond between Na and Cl has got broken down. This bond has got broken down. This has been broken down. But the bond between water molecule has not been broken down. So that's why this process is not exactly hydrolysis. Alright. Now, this is the whole molecule, NaH2O. This is the whole molecule. What happens? Here, when you will add up this H2O molecule, will react with this H2O molecule, what will happen? This will break down. The H part, the proton will get to associated with another water molecule, and the OH will remain into this molecule. Alright. So here what breaking down of this molecules is happening, or this water molecule is happening. Whether this is breaking down or this is breaking down exactly, this could be find out by isotopic leveling, but here there is a breaking down of water molecules. So it seems necessary that in a hydrolysis process, the water itself should have to broken down into two parts. Alright, if you just try to look at the mechanism, what would it have been? Mechanism, then it would be more clear, I guess. Mechanism. Let's say this is what we call water molecule. Now if the water molecule, which is a neutral water molecule, attacks to this, what will happen? Because this is a polar bond, this is the polar bond, electronegativity of oxygen is high. If this is partly shifted toward this, means it is delta negative. Here it is what? Delta positive. Alright. Oxygen also has delta negative. So this will attack to this part. Okay. This will attack to this part, and the resultantly this will move like O negative, H2O and OR. This will get formed. Alright. Now here you can see that this will also get positive charge. What will happen? What will happen? This will accept readily a proton from what? Water molecule. This will accept a proton, and this proton will get transferred to this side, proton transfer. And this would like be, no sorry, this is not going to happen this way, rather just look at this point. This is also very crucial step. Even people do write in a two different way. There may be books who will be writing in a two different way. What will happen? Some books will write what? Some book will write what? Some will say the proton transfer exactly because this is a positively charged. The oxygen valency has already got exceeded. Now oxygen valency here is what? 3. So this will try to release 1 proton so that could restore its original valency of 2. Okay. So what will happen? Somebody, yeah, some books or some kind of instructors may deal that these protons get transferred to exactly this position. Alright. But you can see this is a charged here and this is the neutral lone pair of electron. So usually the first electron will get transferred to here. But if this happens, reaction is not going to proceed. If this proton gets transferred to this position, reaction is not going to proceed. Alright. But if this proton gets transferred to here, what will happen? There will be positive charge. There will be positive charge. Again R will gain positive charge. This is very easy to break down this bond and this electron pair will move down and they will restore its normal structure of OH. So that's why this process happens. Okay. Ultimately my meaning here to say this get hydrolyzed. Alright. And in this process what happens? In this process what happens? You might have heard in inorganic chemistry that when there is something called beaker and there is a fill of water, you add to this what we call NaCl. What happens? Na plus Cl. What happens? It's like that. Na and Cl. This is a negatively charged, this is a positively charged. So what happens? There is a water molecule, there is a H, there is a H, this is positive charge, there is a negative, this is a negative charge and there is a what? Positive charge. This part will interact with this and this, this part will interact with this and this part will interact with this. Okay. This process is called what we call solvation or hydration. This process is called. Means stabilization of sodium plus ion or chlorine negative ion is being done by what? Water molecule. Okay. Alright. In inorganic chemistry, even things happens in a more critical way. Let me redraw it outside. What happens? When NaCl molecule is put into the water, this is the ionic bond. This has to be broken down. Alright? There is a surrounding water molecule. Here is a positive charge, negative charge and positive charge. Here is our surrounding molecule, HH, positive and delta 2 negative charge. This is a positive charge. Alright. You know there will be interaction in opposite charge. This will be interacting by this side and this will be interacting by this side. Alright. Means this dipole interaction pulling it away from toward this, and this dipole interaction pulling this sodium ion toward it. This water molecules with the dipole of hydrogen atoms interacting with the chlorine negatively charged counterpart, and what happens? This is trying to take away with themselves and this is trying to take away with themselves, means these two forces are opposing each other. So finally this ionic bond will get broken down. This is a convenient way of explaining things. Otherwise in scientific language what happens? If there is a two interaction, you know, when there is a bond formation there is a release of energy. When there is a bond breaking, it requires energy. Because you are breaking the bonds, it is doing some work. So you will require to do this work and that work will be some form of energy. Isn't it? And if you are forming the bond, of course there is attraction between two charges, the potential energy will go down, so the energy release will happen. Alright. So this interaction lead to a release of energy and this interaction lead to a release of energy, and this requires a bond formation. Bond breaking requires the energy. So these two components of release of energy will complement the breaking of what? This NaCl bond. And if these two energies these two energies which is being released by these interactions are the energies required by the amount of energy to break this bond. If it's equal or greater than this requirement of breaking this bond, then only any salt will dissolve into water. And this is where what we call, because this process is called what? Hydration. This process is called hydration. Alright? This process is called hydration. Alright? So this hydration is a reason for any salt to dissolve, because this releases energy. And one formula that you often read in a what we call a normal inorganic chemistry, when hydration energy He exceed what we call lattice energy, then there occurs solution, then occurs dissolution. Means if you are putting NaCl in a water, means what? If the water will try to hydrate the NaCl molecule like this, and if this hydration energy is higher than the what? NaCl lattice energy, then this will break down this NaCl molecule and finally we get dissolved. And if they will got broken down, what entity would be formed? This kind of entity, this kind of entity. And you will be surprised that this entity is not exactly a chemical bond formation here. There is no chemical direct bond formation here. Otherwise, you could have separated it in weaker or test tube. So there is no chemical bond. It is just a physical interaction. What we call physical interaction. Physical interaction. Okay. So dissolution basically is the process which is dominated, which is governed, which is driven by what? Physical interaction. There is no chemical bond formation. It is just what? Dipole-dipole sort of electrostatic physical interaction. But when there is a bond formation, like here in the cases, here this is a business of bond breaking and bond formation, exactly. Here we are breaking the bonds, but we are not forming the bonds. Okay. So that's why this process is basically physically controlled process, and this is a chemically controlled process. So up to dissolution stage, this process is in the control of physical processes. That's why the hydrolysis, which is purely a chemical reaction type, though this term would not apply to this case. But when there is a bond form breaking and formation together, now you can see that what the proton of this water molecule has been snatched away by this water molecule. So there is a bond breaking and bond formation. So in Lewis-Bronsted acid concept, basis concept, this metal ion complex is working as a what? Acid. Lowry-Bronsted concept of acid and basis. This is working as acid. So basically, this is the part of what we call dissolution, solvolysis and dissolution process, and how this metal ion, this is a very interesting metal aqua complexes are getting very interesting things to be studied. How they are doing this business, what we call the acidity of what metal aqua ion complex, and this is a very good interesting topic, very often asked in competitive examinations and even written examinations. So I will just take this as a subject of study in the next lecture. Okay. So we will close it down. Next lecture will be this one. All right.